Hello and welcome to our webinar, Innovating Healthcare with Real-Time Analytics in the Cloud. Today's presenters, I'll be presenting for Amazon Web Services along with Jordan Martz, the Director of Technology Solutions at Attunity, and Jeff Graham, Principal on the Big Data Analytics team at Fuse by Cardinal Health, which is the Innovation Center of Cardinal Health. Today's agenda. In this webinar, we will discuss how AWS Cloud and AWS Marketplace accelerate cloud success, how Attunity moves data into AWS Cloud in real time and with zero downtime, and how the Cardinal Health team leveraged their data using our technology to provide innovative healthcare for their customers. After you hear from each of our speakers, we will open the session up to you so that we can answer your questions. Our learning objectives. Our learning objectives today are how to move data real time securely with minimum operational impact. How to set up data lake on Amazon S3 quickly and easily, and how to use Kafka to get more value from data. So big data on AWS. The big data pipeline can be described in 4 steps or stages. The first stage is ingest, where the data is being consumed or taken in, and immediately afterwards it's stored somewhere, otherwise you're going to lose the data. Then the stored data needs to be processed, and this process data could be used for analysis or for building predictive models. So AWS has services that offer. There are services that fit the requirements in each of these buckets or stages. In the first stage, the ingest stage, which helps you absorb or ingest the data, as the name suggests. The relevant services here are AWS Direct Connect, Amazon Kinesis, and AWS Import Export. AWS Direct Connect is the service which lets you get a private connection to AWS data centers. This can be a 10 gig pipe. This lets you bring your packets from your data center or from your corporate offices to Amazon AWS directly without having to go through the internet. This provides you privacy and isolation from the rest of the internet. Amazon Kinesis is a streaming service which helps you collect streaming data. And AWS Import Export lets you import large amounts of data through our other services like Snowball, etc. So you ship your data, and this automatically gets uploaded to S3. And of course, you have Attunity in this stage. Once you have the data ingested, the next stage is to store the data. The way to store the data is the primary service to use here is S3. S3 is object storage. It has very high durability and availability, especially availability as durability. It has 11 nines of durability, and that is the primary way to store data on AWS. It is blobs. You store data as objects. It is not structured in any way except the key value pairs. The key and objects pairs, sorry. Amazon Glacier is an archival service attached to S3. So in case you have archived data that's older than a certain amount of time, and you know for a fact that you're not going to be using the data frequently, you can push this data into Amazon Glacier, which for long-term usage. This reduces the cost of storing large amounts of data. So those are the top 2 services shown in red here. These are not structured. So if you want to store the data in a structured format. You could use Amazon Redshift, which is a data warehouse, terabyte scale, massively parallel data warehouse. And that is a relational database. If you have a NoSQL data, you could use Amazon DynamoDB. If you are interested in having any other relational database like MySQL or Postgres or Oracle, you could use Amazon RDS. These are the three managed database services that we have today. After you store your data, the next step is to process the data. To process the data, you could again use these three services. Amazon Kinesis comes up on the top of the list. This Amazon Kinesis has the ability to process the data as the streams are coming in. So that's a very valuable service if you want to have a near real-time analysis of the streams coming in. You could, of course, use Amazon EC2, spin up your own instances, process the data. Or if you are interested in having a MapReduce application, you could run it on Amazon EMR. Amazon EMR supports several other open source MapReduce programs, including Flume, Mahout, and you can see the long list of software supported, including Pig and Hive and so on. The next step is to analyze the data that is now processed using EMR or other EC2 or Kinesis. And the services that we offer today for that is QuickSight. QuickSight is a visualization tool. It can be considered as a business intelligence tool that helps you to see the data and understand the trends and patterns in the data. This can be used for presentation as well. Amazon Athena is an interesting new service we launched recently. This lets you process the data straight from S3 instead of going through a separate processing step. Right after you store your data in S3, you could have Athena access this data and run SQL queries on SQLite queries on the data that is stored in S3. That provides a level of flexibility or for quick access that is not available in other methods. Or the third option is to use Amazon Machine Learning. This is a service which lets you run machine learning algorithms to create predictive models on the data that is stored. Amazon Machine Learning can use the data in S3 or can also read from Redshift, the data warehouse, very massive scale data warehouse service. So we looked at several services, and the people usually ask me, customers have asked me, like, which is the service that I need to use for a certain use case? The answer is it depends on the timelines and it depends on the scale that the use case warrants. So let's look at some one specific aspect of which service can be used for which case, especially the data storage. So this is an interesting table which showcases the different storage methods and the query complexity. So the x-axis talks about the query complexity, where the query complexity ranges from like really simple queries like, hey, here's my key, give me the object, or NoSQL, where you give a key and then you get a value. On the y-axis, you have we talk about the complexity of the data itself. The complexity of the data itself, meaning, so if you look at the bottom leftmost corner, you can notice that if we talk about S3 and Glacier, which is the way the query is just you ask for a key, it's going to give you a blob of data. And on the bottom right, we're going to talk about storing the data that is not structured, but the query complexity could be very high, right? So if you store data in Amazon Cloud Search, or you can store data in S3, and you can access the data and query this using Hadoop or HDFS or using Pig or Hive. On the other hand, if you go to the top orange bar or yellow row, it talks about how the services that can handle more complex data. So the structure of the data stored in Elasticache or DynamoDB is slightly more complex than what you would store in Glacier. But it lets you query in a slightly different way. You can have scans and have indices on the NoSQL. And Elasticache is also somewhat similar. On the top right is the other extreme compared to S3. Like on the bottom left is one extreme where the data complexity is low and the query complexity is also low. On the top right, you have the data complexity being high with relational data, and the query also can be as complicated as you want it to be, as long as the database allows it. This includes Amazon RES, Relational Database Service, or Amazon Athena, which lets you query again on S3, but you can have complex queries. And of course, you can have Amazon Redshift, which is a data warehouse tool service from Amazon. So based on your use case, based on the type of data, the complexity of the data, and the complexity of the query that is required for your use case, you can choose the right tool for the right use case. All right, and now let me turn the presentation over to Jordan March, Director of Technology at Attunity.
Thanks, Pradeep, and thank you everybody for joining us today. It's a really nice day to share some of the exciting stories that we've had with not only with Amazon and Cardinal, but with many other customers. Where when you look at the descriptions that Pradeep is discussing, one of the things that you look at are all the different ways you have to ingest them and the aspects and complexities of doing such. So when you're building these scenarios and you want to make sure that customers, they want to go into real time, they want to build an infrastructure that can handle for that, Attunity Replicate becomes a paramount tool for delivering that value and being able to do that. So what we have is a partnership with Amazon that if you go to the CloudBeam website, if you go to AWS Marketplace and you Google for the CloudBeam solution, you can look at how we're loading into S3, into Redshift, and we've got a 5-star rating on that. That means our competencies are helping you with data migration, moving data into the S3 infrastructure or loading into any of the other topics such as Kinesis and other components, but the overall big data landscape that you would need to be able to leverage all the host of tools. I mean, it's exciting. The UI and ClickSite's really easy to use, or being able to use Amazon Search or loading into DynamoDB. As you're looking at all those different solutions, we're a key component of being able to make sure that your hosted on-premise systems can then move into those overall scenarios, and the use cases for those are many. There's IoT, but also just business data solutions that need to be addressed. And when we look at an easy-to-use, out-of-the-box solution, CloudBeam's really easy to actually not even download, but to go to the AMI that's hosted on EC2 and be able to use that to then move your data into Redshift in a very automated and easy infrastructure, and also a nice natural flow. So today we're talking about very easy to use solutions on AWS. And what we do is we have these considerations for loading efficient data migration tools, how to analyze data, and how to analyze data in every format. So we have 40 different sources and targets, but the key sources are going to be relational databases and mainframes, and being able to move those sources that are containing not only core data when we hear about big data, but also reference data and those other key assets. So you want to be able to analyze data from anywhere. You want to be able to pull in whatever data is inside those systems and be able to analyze everything there. But at a key level, it comes back to the real time, and that's where I started. Was there's this idea that as you bring all of my sources and all of my applications into a real-time data lake or a real-time infrastructure data warehouse like Redshift, you need something that's constantly loading that infrastructure, and Replicate delivers that solution. That's the key here. So as you're building that and you're looking at different ways that you can ingest our technology from the Attunity standpoint, you want to look at CloudBeam as one way to download it and pull this down, or contact us to help you with that overall experience. There's the other aspects of data replication, which is the impact at the source and the ability to develop those tools and solutions very quickly that allow you to be able to replicate the data efficiently and do it in a way that creates this light impact. I mean, when you're downloading your day-to-day applications and you're clicking through your websites, you don't want them being affected because you're moving a lot of the core information that's running across thousands of reps or doctors or patients or machine systems all over the different business, moving them in. And as you ingest and stream those data warehouses and the databases and even into the big data, all of these need to be coming in so you don't have to worry about the considerations of loading. As we look at Replicate, it's used by hundreds of enterprises worldwide. It's got a significant footprint inside of many, many businesses as a universal tool for making it very easy and efficient to load with such a minimal impact. So feel free to download the tool and play with it, but just to get the idea of how easy it is to build this out at a large scale, which is what we talk about with our partners, with Jeff and the Fuse by Cardinal team. There's also loading into the Amazon cloud. And as Pradeep was talking about, there's different facets of loading. There's BI applications on a data warehouse like Redshift. There's the RDSs, which are these relational databases that are hosted that you can then migrate to and from and help you with your overall infrastructure migration plans. What are that data element that's going to bring you across those systems and across that infrastructure to be able to load? There's also S3. And a lot of folks are loading into S3, not only from content of video files and a lot of the big use cases, but there's pure business application data that can be queried using EMR, and it's very redundant and available. So when we load, we make it real easy. And there's also file replication. There's the ability to move files throughout AWS and throughout EC2, and we offer some services that are very easy to integrate that. Lastly, there's the kinesis. There's the real-time use cases for streaming applications, driving a lot of those IoT use cases. When you have data today, a lot of it's orphaned immediately, so it's not actually utilized. And then there's the aspect of how I can make sure that what was collected can be collected and aggregated in an efficient manner over time. And the other one is how do I run analytics over it? And lots of easy aspects to this overall solution. And that's what we're here to bring. But what are the considerations of change data capture? When you're loading a lot of this data, what are you trying to do? Well, there's 4 key things that you're looking to look at, and we have a versatile platform such as like real-time infrastructure, or we have real-time grouping, so a small batch of records needs to be brought across, but also combined with the net new target source. There's also the aspects of a data warehouse and how change data capture loads into those in an optimized manner. And then there's that kinesis terminology that we were talking about, which would be these message-based scenarios, even like a Kafka if it's hosted on an infrastructure on AWS. So light impact, flexible options, capturing the data, that's key for our overall infrastructure and how we load. So those are the 4 considerations of a CDC tool and why to look at it. And you want to make sure that it's always considered to be an in-memory and file optimized format for being able to do this. Next, what I'm going to do is talk about all the sources and targets. And there's many different sources on the Amazon platform that we load into, like we were showing, like S3 and EMR and RDS, but there's so many sources that you have in your business. You could be able to take that real-time mainframe and move it into Amazon, or connect to SAP at the application layer and move it across. So lots of different unique use cases of your production systems that we can take that often have complexity to them and bring them into Amazon and also bring them into the operational systems that are running your business. So that's what the Amazon the Amazon infrastructure offers, is so many different ways to load from so many different sources. I think in Jeff's case, he's so much complexity from running, which is one of the larger companies in the world, with all the healthcare systems and all the ways that they integrate. They have so many different data sources, and I think that may be a factor, and also other tools that are in the market that we integrate very natively with and make it a very easy to use experience for both the customer and our partner Amazon to be able to support and work together. Lastly, there's something really unique about us, and I think in this use case, this is a unique tool that the market. There's very few market tools that offer this solution, and what it's offering is a way to load that infrastructure, like in Redshift, that data warehouse, using our replicate solution, and bring in its near real time as you can process the data, actual full agile data warehousing, managing the data definitions of the tables, all the way through those inserted, updated, and deleted records, that automation of the ingest, the actual structuring of the data, and continuous updates, not just to the data itself, but to the infrastructure of the actual warehouse, being able to transform it and load it over time and make it very easy to use to be able to do this. And that gives you very key flexibility for this overall solution. And that's where Redshift has come in. And when I look at the different tool, there's the terminology of ELT. This is the ETL process that's right in the middle of the screen, but you could take your Informix or your DB2, MySQL, any other data warehouse that you're using, and map it and extract it into some landed zone of tables and compose with it, model and manage across that very complex process of loading data warehouses. It manages all of that, not only through design of the tables, but also the transformation and the changes that occur over time to these data warehouses. So I think that when we look at the different solutions, we're able to bring complex environments together. We're able to land a lot of that data together. We're able to manage and transform that data. And some terminology that often becomes the key is thinking in real time. And businesses don't really think that way. Our lives are with search engines and everything else, but I think as you look at the different tools that are in the market, and as you're looking for different ways to be able to manage it, look for something that's very unique in the way that it can handle so many scenarios, very easy to use, something that's built to scale for very large companies, and also something that that's relied on by many others. So I wanted to say thanks, Pradeep, and then what I'll do is I'll introduce Jeff here. Jeff has a very unique and interesting use case, and Jeff, I'll let you take it away.
Great, thanks, Jordan. Thanks for everybody for joining. Just to give you a little background of Cardinal Health, we are a global healthcare services company. We create customized solutions for hospitals, health systems, pharmacies, really across the gamut of the healthcare industry. We are a Fortune 15 company, so like Jordan was saying, we do have a pretty good scale in the amount of data and the number of contacts that we have. I believe we're in 70 to 80% of the hospitals throughout the country. So that does give us a challenge in how we can leverage that data across the enterprise. Moving on, so there's been a few references to Fuse. Fuse is an innovation center. We launched it a little over 3 years ago, and it was really to look at innovative ways that we can create new items, create new insights across healthcare, and it's really kind of a change agent for Cardinal. It allows us to work with customers side by side and understand their challenges and really help transform the way that we approach health and wellness. We're compared to our mothership, so to speak. We're a smaller organization. We have about 120 people within Fuse. A little bit about myself. I'm the principal data engineer in Fuse Labs. I'm responsible for the big data technology and also the data science that goes on. And probably most importantly, I'm a healthcare analytics evangelist. It's pretty exciting with the convergence of EMRs and IoT and just all the data points. As everybody knows, in many different businesses, data has just exploded, and how do we deal with that? How do we create opportunities about that, around that in the healthcare environment? And it's a pretty exciting time to be involved with that. So when we started out with Fuse, we wanted to look at how do we approach healthcare data, and how can we really do that in a better way than what's traditionally been done. My background before coming over to Fuse was I helped build the big data practice about 7-8 years ago for the corporate environment, and we learned a lot of lessons on how to leverage big data across the enterprise. But we knew that healthcare, when you deal with like clinical data, when you look at regulatory science, there's different challenges there. And so we wanted to take that opportunity from the beginning to kind of answer some of these questions, or try to answer them. So what we looked at is how can we handle a variety of data sources with a minimum amount of moving parts. We wanted to, simplify things. How do we handle, and this is a common problem, how do we handle bulk historical loads and real-time data elegantly? A lot of times organizations will try to split those up into two different things, but they're really one and the same, and how can we deal with that in a similar fashion? Paramount to Fuse is playing nice with source systems. So at Fuse, we're looking more at external clinical systems. So how do we play nice with those? How do we minimize the footprint? And most importantly, how do we minimize any performance impacts? And Attunity and AWS really help out with that. Furthermore, how do we replicate data into different data stores and analysis tools? It's not just relational databases anymore, and for good reason. There's a lot of benefit in different data stores like graph analysis. So how do you look at things from a machine learning and natural language processing standpoint? So those require different data stores in most cases, and how can we move our data into those different data stores and analysis tools without having unique piping to each one of those systems? And then finally, and most importantly, how do we minimize the time spent on data migration so we can focus on analysis? Because we don't really get the benefit out of moving data from point A and B. What we get is benefit out of analyzing that data. So at the end of the day, we really want to approach it as Albert Einstein said, everything should be made as simple as possible, but not simpler. So ironically, with all the complexity going, we were driving for elegance and simplicity in this approach. So I'm going to give you a little bit of background, just kind of a high level of how we approached those problems. Most all of our work is out in AWS, and which is really challenging because we have a lot of security constraints, and AWS is really able to meet those. We're bound by HIPAA regulations, so there needed to be a lot of, besides technical processes, legal processes in place, and AWS has been a great partner in that, as well as Attunity, because Attunity's really helped us simplify things. I'll go a little bit into how we do that. We use it as a Lambda architecture, and Lambda kind of gets overbaked a lot. You probably hear it a lot. It really boils down to how do you handle those batch historical loads and real time together. So we're looking at Lambda from that standpoint. And what we're looking at is how do we move that clinical data from kind of your legacy SQL systems into AWS. Therapy research is a big area that we work on. And it gives us a big advantage in doing that in the real time. Real time was mentioned a couple times. We really look at feedback loops. Feedback loops determine a lot of where and why it's important to have real time, and we can probably get into that later. What we're looking at below, if we kind of go from left to right, the clinical systems, they're running on RDBMSs. We use Attunity Replicate to actually do log replication. So Attunity is looking at the transactions when they're committed in the database. That's when Attunity can pick them up, and they're not picking them up through queries, direct queries. They're looking at the exhaust off of the database. Those are then plugged into a message queue. The message queue in our case is Kafka, but Kinesis is another tool that's very similar. It's just the idea whenever a transaction is committed in that source database, how can we quickly get it into that message queue, and how can we get it in the correct order so that we kind of have a play-by-play of what happens in that database. And that message queue is really like a your first location to drop data, at least it is for us. And from there, it kind of flows into two places. When we bring up a clinic, when it starts loading in data for the first time, the first thing we need is its historical data. So that box up at the top kind of describes how we do the historical data from a batch standpoint. This is one bolus of data, if you will. That's dropped in through Kafka, and then we take that over to S3 to drop it into these different data stores off to the right. Real-time's also handled from that. It's still sourced through Kafka, but there we use more of a microservices architecture to handle those stream processes. So once you have the historical data landed, so you have context, as your new changes are coming in through the day, you can react to those changes and take a look at your historical context to know how to react to a situation that comes up. And we do that through a variety of things. Like I mentioned, we have different engines to handle the structured analysis that never goes away. SQL does not go away anytime soon. Graph analysis, how do we find out patients who are taking similar drugs and having similar outcomes? How do we kind of find out how drugs are related and how they're used within clinics? That's in graph analysis. Natural language, that's really important to us because doctors have copious amounts of notes that they keep track of in a healthcare system. So how can we kind of pluck those important pieces out of the notes? And then finally, this is really a growing area for us is machine learning. How do we move away from the deterministic heuristic models and move into some of the cognitive capabilities that are out there that are really starting to develop for us? When we look at neural nets, how can we build more complex webs of cognitive understanding? Those are really starting to develop for us. So the important part to take out of this is we want to be able to pull data from those data springs, if you will, put it into a system where we can move it from the data stores in many different data stores, and also handle that large batch bolus of data in the beginning and then react to the changes as they come through. So the implementation, and maybe I've already covered some of these, the implementation, we knew that RDBMS log-based replication was the best approach. We did it before in the enterprise. It made it easier for us to work with those source systems because no one wants source systems going down just because you're moving data to an analytics data store. Security, 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 and I hear about it every day. Everything needs to be encrypted in flight and at rest. Those are really table stakes. Everything we do needs to operate around security, and AWS and Attunity fulfill those needs for us. We really looked at cloud-native modern design principles. That's a whole other topic, but it's just approaching things in a different way. Cloud's here. It brings huge benefits. We need to understand and think like a cloud company. Furthermore, we needed an easy button. We needed a way for partners to install their systems. Jordan mentioned downloading Attunity and start to use it. It's something that we can install in our partners' clinics, and we can manage it easily. That was a very important part to us. And then finally, cost effectiveness. And that's cost effectiveness not only in the tools, but also in the ongoing care and feeding of the system. So we did all this work, and what are the results? Hopefully we have good results, or we wouldn't be in our jobs any longer. Results, flexibility. We can source unknown data sources in the same day. We do not have to know the particular system and all of its nuances day one in order to start extracting data from it. There are some, I guess you could say there's some table stakes. We need to understand what the data store is, the RDBMS. Jordan mentioned all the sources and syncs that are involved with Attunity. You do need to understand those, but you don't need to understand the schema right away. You don't need to understand how all the data connects and relates right away. We can start sourcing that into our system. In most cases, we already know about it, but it's not a prerequisite anymore. Management, this is huge for us. Like I said, we're a smaller team. The data science team, we don't have a ton of people in the data science team. Before, all of us were spending one way or another time shepherding data through, and that adds up really quickly. It's kind of one of those unknown expenses because it's far under the covers. We were able to go from all of us doing some type of data shepherding to having a consistent system where really it's half of a person as we're going through. And again, we're pulling from many different data sources. There's a little time to actually onboard a data system, but once it's up and flowing, for the most part, it takes care of itself. And that kind of gets back to our focus, is our teams get to spend time discovering trends and insights and not moving the data around. We want to have a process, an elegant process that moves it, is consistent, but once we have that in there, we want it to kind of run on its own. And so this system kind of does that for us. So that's all for me. I guess I'll hand it back to Jordan.
Perfect, Jeff. Thank you. And thank you, everyone, for joining us with all of the different aspects. What we're going to do now is we're going to move into the Q&A phase, and maybe we can start to ask some of the different questions that are coming in. So what we have right now is I've got my initial question from some of the guys, which is asking about the advantages of CDC functionality. And Jeff, you marked some of them, but what was your driver with CDC functionality from some of your sources and even externally? What were your key things? And I'll just chime in right after that.
Yeah, sure. Besides, when I was talking about CDC and log replication, we refer to that as working off of the exhaust of the database. So the database really doesn't have to do much more work in rendering us the data. So that's number one. And then also just the speed, since we are streaming data now. A good example of that is some of the systems we built around compliance. Since we are able to tap into what the doctor's clinical system is doing, when he enters in something or the provider enters in something, we can react to that very quickly. So it's that real-time aspect of, as a provider is entering data, we can look at that, compare it to our history in real time, and then give a compliance score. If you go into recommendations, there could be recommendations made. So it's just that feedback loop. Traditionally, systems before this, healthcare professionals would receive insights on data that was maybe 3 months old or 6 months old, and imagine driving your car down the road and not having your speedometer. You need that feedback loop to navigate safely.
Yeah, exactly. And I can't agree with you more. I think there's a lot of exciting things that you guys are doing, and you've already addressed my next two questions that we had come in early on, which one of the early folks were asking about loading data, which you addressed, and how you do it with Kafka and also with Kinesis. But can you talk about when you guys load into Kafka, how do you guys just decouple some of the messages? Because I think this applies to Kinesis too, and how you guys handle for that type of scenario.
And just a quick question on that. When we talk about decoupling, are you saying that really Kinesis is that middle store?
No, like the message structure.
Okay.
The message structure, yeah.
Yeah, how do we decouple that? So that's a good question. And I'm sorry if I get a little too geeky and cut me off, but if I do, but as that log, as Attunity reads that log off of that database, it really wraps each one of those transactions up in a message. That message contains the data as it sat on the database and tells us what it changed and kind of tells us how to deal with that on the target system. So that message not only has the data, but what to do with that data and how do we send that on to other systems. So that decouples the landing of the data into Kinesis or Kafka from what to do with it on the other side.
I think it's a really good, clear way to go. And I'm going to move this over to Pradeep now, and maybe Pradeep, you can help us both. We can talk through this one. We have a question right here where they talk about some of the features that you have in native AWS and in Attunity, similar, where you've got use cases with DMS, and also long-term replication. So where you have use cases on performance and abstraction and other features, can you help us with some of those aspects on what Amazon has, and I'll help complement after that, where Replicate, Prateep, how Replicate can help complement the Amazon solution.
Sure. Yeah, I can handle that. So Amazon DMS, database migration service, lets you migrate from one database to another in AWS. Maybe you can go from Oracle to maybe Aurora or something of that sort. And this DMS is being used to migrate, I think, more than 20,000 databases so far, or even more. This is probably more now. Regarding whether this DMS versus Attunity replicate, I'm going to forward that to the Attunity folks on the call to answer that.
Sure. So it's actually interesting because we each have unique partnerships, and I think that the DMS service is fantastic, and I think Replicate has a couple more endpoints, such as mainframes and SAP, which is where some of my next questions are going. But what we have is that there's different performance and there's abstractions and other things. Both of them work very similarly, but there's also a question that came down from one of our audience that asked about transport protocols and the rest of those things that come into Amazon. And I'll help answer that, and then Prateep, you can talk about this. It's just the ability to move data across such a complex regions and those things with transport protocols and having to deal with all of those. Maybe you could talk about some of the message SQS and other things that go on across Amazon after this. But Attunity Replicate under the covers has a lot of that automation around transport protocols under the covers. But I think that the complexity of your environments that would come from JMS and different kinds of messaging systems, AWS has a lot of stuff built internally to handle for that scale. So Prateep, I'll let you mark to that. It's quite a long question.
Yes, it is. So thanks for that. Yes, definitely. If you take the overall services that we offer, it comes down to how you want to architect, and that depends on what you already have, what you already tools are already using. So you could use SQS for message passing, or you could use something else like what he said is JMS. So it's a combination of things that really matter. So I would highly encourage you to try it out. And that is going to be my answer for that question. The other question that I really like was the visualization tools used for dashboard and custom analytics. The visualization tool that we have today in AWS is called QuickSight. That can read from S3 or Redshift or other sources. So that is, and we also have other partners that provide dashboard services. Go ahead.
Yeah, I can mark some of those that are coming in. This is Jordan, and we had some questions around SAP migration to AWS as well as in HANA migration. So at the time, we don't fully support HANA yet for the application level extraction, but we will very, very soon. And I think that's one of the exciting parts about the way that we're extracting from SAP, being at the native application layer. So we built a hook into the actual application tier, but it does replicate from the database. It pre-maps and pre-figures out the timestamp and how the depth to go into those tables. So that's key. And I think there's another question around real-time replication, around why, when you extract from those databases, why you would call and insert, update, delete at the log file and extract from there. So I have another one for you, Jeff. Why did you pick a microservices architecture instead of a stream processing architecture?
Why did we choose a microservices versus a stream? Really, we kind of look at those as similar things. Microservices is just an architecture where you split up into atomic units of work. And really, those atomic units of work in a microservices architecture support your stream processing. So an example of that is on the real-time side, we actually have topics that we're listening to inside of Kafka. So that microservice, one of its jobs is just to listen to that topic. And as messages are coming in, it'll react to it. So let's say that you're piping data. No, let's make it simple. Let's pretend you're piping data into a graph database. It's listening to those and then translating that into a gremlin or a cipher statement and placing it into the database. That would be one microservice. Another one might be, hey, I'm looking on an event. I'm looking at the messages, and when an event comes through that there was an office visit, maybe I want to pipe that to a machine learning algorithm that sits there and says, okay, I know a particular patient. Let's look at the history of that patient, and based on their current visit, what are some of the recommendations that are created there? So those microservices architecture really support that idea of streaming data through. So to me, they're one and the same, answer to your question.
Yeah, and I think that was what I was looking for. I think there's a lot of complexity in today's market when you migrate to the cloud. And one of the questions we now have is, when you migrate existing applications to AWS, you're building new applications to retrieve that. So you seem like you've done a lot of new built new innovative applications. You've looked at new metrics. You guys have derived new systems. Whenever you're doing this on the Cardinal side, have you guys come to a conclusion that have transformed the on-prem infrastructure? And can you talk about some of those applications and some of the learnings from migrating to the cloud and the new use cases that come up?
Yeah, and it gets harder as time goes on because, like I mentioned, on being a cloud native, the more we've worked in cloud, it just kind of becomes natural, and the longer you work in it, the harder it is to realize maybe the older way of working with on-prem. You know, on-prem would take us, several months just to stand up infrastructure, which really with Fuse and kind of our innovative bent was difficult because we needed to test out hypothesis, right? We needed to do hypothesis testing. So how could we set up a system really quickly, do an experiment, try things out, if they succeed, move forward on them and scale them up, or if they fail, shut them down with a minimum amount of cost. So those are our big motivators for working out on the cloud and why it still works for us now. And to your other point about we still have to go to on-prem if that's where the data's at. If the data's residing in a healthcare system and they're on-prem, it creates a unique challenge, right? If you have an organization that's used to doing everything on-prem, how do you kind of work through that barrier of, we're going to move stuff into a virtual cloud environment? How do you work through that? And that's a lot where Attunity makes it easier for us, because first of all, we can prove out the security, we can prove out that it's safe, we can have all those safeguards in place, but we can make it really easy for that new group that is used to on-prem to kind of embrace that technology and make it easy for them to use.
We only have a couple minutes left. And Pratap, I'm going to ask you about some of the archival questions that have come in. So what kind of archival, because I get a lot of questions about SAP and migrating to SAP and the rest of those things from one cloud to another, but it's all backing up and the rest of those components. So can you help us with that? Like, how do they handle for those scenarios?
Sure. The main storage service that we have that is used for archival is S3. So the idea behind S3 is it's a very high durability service with 11 nines of durability, and the fact that it's highly durable comes from the fact that it's distributed across multiple availability zones, and that gives it the durability. Now, S3 is very cost effective, but when you have it in S3, it's still it's intended to be used frequently, and you could use it. So it's charged for storage and for the amount of the number of requests that you get to access S3. But there might be a case where the recency becomes a factor. Recency means that you would stop using or accessing data that's more than maybe a year old. In that case, you can assign a lifecycle policy that says whenever the data that you have in S3 in this bucket becomes more than a year old, you can push it out into a Glacier. The Glacier is our archival service, which is what we call cold storage. That's the name intends. The cold storage helps you to reduce the cost even further. and it moves from the S3 bucket to a Glacier. You can access you can access Glacier, but the way to do it would be when you access Glacier, you're going to have really high. You need at least a few hours for the data to be retrieved from Glacier before you can access it. So because of the nature of the storage that it uses. So and you're going to be charged based on the amount of usage, and it's intended to be not used frequently, not used every day, but as and when needed, with long pauses between.
And I think this is going to segue into our last question. It's for Jeff, and it's generally a question around the data at the source. Once you migrate it into your data lakes and into your new repositories in AWS, what were the learnings and what did you keep from that source? Do you guys maintain that over time? It's a two-pronged question, and that'll be it for us, guys.
Okay. What did we learn? First of all, let me start with what did we source from the systems. HIPAA is a pretty complex requirement. One of the aspects of HIPAA is minimum use, which is also used in many different ways in HIPAA. We want to look at the minimum amount of data that we need to do the job. So, contrary to maybe some other systems, we don't pull everything. So we have to be selective in what we pull. Once we keep it in there, we keep it in the system for as long as legally allowed. It's really not a space issue or a processing issue to us anymore. It's really around a compliance issue. So the more history we have, and most data science efforts, the more accuracy we can get, the better trending we can get. So we try to keep that around for as long as we can. Sometimes there is need to expunge data, so you need to have processes in place to do that. So that's equally as important. Depending on your project or what you're putting together, if you can hold on to that data forever, if you can send it off to Glacier, if you can put it on ice, so to speak, all the better, because it's quick to turn that back around. So we don't really have this aspect of let's move data off to tape and maybe never see it again, or it takes days or weeks. It's really kind of a minor point for us. And I'm sorry, what was the other question again, Jordan?
It was learnings, and also what data have you kept once it's on the source systems? Do you still keep it in the source systems, and how much of it have you moved over into the data lake?
Well, the source systems are part of a healthcare system. It's part of the clinical data set. So that's really up to our partners and what they keep in there. What we really look at is what is the data that we can use that helps them out. So when we have that in our system, we need that historical trending data to be able to help them out. So whatever they decide to keep on their systems is wholly up to them.
Okay. Well, I can't say thank you enough, Pratap and Jeff, for your time today. Also to the rest of the audience, I wanted to say thank you to all of you guys for joining us today. Thank you. Here's the last slide to go trial out different solutions. And have a wonderful day, everyone.